Welcome to Building Data Lakes with Azure Databricks. We'll talk about what is a data lake, why they're so popular, and how we build them in Azure, focused especially on using Azure Databricks. This will be more of a data engineer's perspective into building data lakes and how we do it with Apache Spark. My name's Dustin Vannoy. I am a data engineering consultant, so I've done quite a bit of the type of work we'll talk about today on a variety of projects with a few different organizations. I also am a co-founder of Data Engineering San Diego, which is a meetup group. We are meeting virtually for a while now, so you are welcome to join us any month that you can make it. We talk about there, and what I do on my job is a lot of cloud data engineering with Azure, AWS, working with Kafka, Apache Spark, Python, Scala. Most of the tools I use every day on almost every project we'll be talking about today in this session. So the agenda is to cover what a data lake is, what Azure Databricks adds to the picture within Azure, how we query from that, just so that everyone knows what the view of an analyst would be, and then go through a reference architecture of building data lakes in Azure, and then we'll actually walk through some demo code that shows the different components working together. So the simplest definition I can give you of a data lake is distributed storage for big data. I don't think that's sufficient to cover everything there is to define a data lake, but that is the foundation. We're talking about storage that is distributed and will work for big data, typically analytic scenarios. Now, the definition, when we dive a little deeper, I break it into three parts. The first is that it needs to be big data capable. This is pretty much always expected with data lakes. It's sort of the reason they become so popular is we want to be able to store data first, evaluate, and model it later. No more giant backlogs for the data warehousing team before data even starts to get collected and stored. We're going to store it right away, make this accessible for people to drop their data into, and then the analysis and the refinement can happen somewhere down the road. I highly recommend, some people follow this, some people just focus on raw data, but I highly recommend building your data lake into different data zones. And so the names I'm using right now are the raw zone, where you just kind of throw the raw data from the application, from the source databases, throw it in there, and some people have access to that. Then you have your enriched area where the transformed, the partially integrated data shows up, and that's kind of a place where a lot of data will land, and it's really up to each user to understand which areas are okay for analysis that they show outside of their team and which things are just internal to your team. And then certified or curated is sort of that last step where you want data that actually matches the financial reports and the reports that your CEO is going to be reviewing at their monthly meetings. And so not everyone puts this back in the data lake. I highly recommend you try to do this when possible and just try and make the place where data lakes can hold all of the data that an analyst will need. If they need to join this data together, they have that capability. And then it needs to be ready for analysts. I've seen too many data lake projects where the distributed storage piece is handled, everything's great. We don't give people permissions to use it. We don't provide any tools that already we know integrate well and work with the permissions and the storage types we're using. And we don't provide any sort of training or consulting to help them get started. So if someone's new to data lakes but is a really power user analyst type person, you need to make it ready for them and you need to help them get started. So driving more into the why, the first reason data lakes are so popular is we want to store everything. So a whole variety of file formats, possibly a large volume of data coming in. So we need data that's cheaper. We need storage that's cheaper. We need to avoid always having to define schemas and clean the data before we write it in the first place. And we want to be able to scale this thing out over time. Reason number two is really driving into that scalability point more. We want to be able to massively scale this over the course of time. We want it to be easy to add more storage. We want it to be easy to add more processing power when a big job needs to run for 1 hour or our load has changed so much that we need to add more processing power every day for the future. We want to be able to span hot and cold storage to kind of cut down on cost, and so a lot of cloud providers give you that capability to move data into this colder storage where the cost patterns change a little bit, but it still looks about the same to the end user. And we want to pay only for what we need. So we typically don't want to expend money on expensive network storage internally. We would much rather try and have cheaper disks that we scale out and just build in the redundancy, which most of these systems have built into them already. And then reason number three is storage and compute separation. This is something you hear a lot about as you get into the cloud, and with data it's no exception really. So Part of the reason this is great is because multiple analytics tools can work with the same data in the data lake. You don't have to copy it everywhere just for a different analytics tool or a different processing system to use it. It also, though, provides cost savings from the perspective of compute. The processing power in the cloud is going to be far more expensive than the storage itself. And so if you can store on this cloud storage that's cheaper, so we're talking things like AWS, Azure storage, which we'll talk about quite a bit more, Google Cloud Storage, those types of storage systems in the cloud are way cheaper than running a virtual machine all the time that has enough processing power to do your ETL or analytic workloads. And so we can spin those analytic workloads and that processing power up separately. Teams can choose different tools to do that. You may need to provide some governance on that, depends on the size of your organization, but we don't have one tool to use them all, and we just have to keep scaling that server up bigger and bigger and bigger to meet the needs of the organization. But what about a data warehouse? This is the only time I'm talking about data warehouses today. So a data warehouse I define a little bit differently. So we are talking about structured data in a data warehouse. And this data has been processed and it's ready for analytics use. So that certified or curated layer of your data lake, that data probably exists in your data warehouse also. That's what I would recommend in most cases. The interactive query capability. So we will see querying a data lake. We will see that we're talking seconds, minutes sometimes to query the data from a data lake. It's not quite the same as connecting to Azure Synapse SQL pools, if you've got a chance to work with those yet, or it used to be called Azure SQL DW. If you've worked with Redshift, it's not exactly the same. Data lakes are going to be serving a different use case, and so the interactive query is not quite as high a priority. And then BI tool support. So we're getting better and better. Honestly, Azure Databricks supports connectivity from Power BI, Tableau, all these tools that you would expect to use. But the way you work with it, you probably aren't going to keep a live connection that a bunch of end users hit on your server. You would more likely export bits of the data into your analytics tool. And so the data warehouse can be more of that back-end kind of hot cache of data, that really fast cache of data for those queries. So let's talk about querying the data lake. And so the tool that I'll be using for querying the data and later on for loading the data is Azure Databricks. Azure Databricks is branded as a unified analytics platform. So what that means is some of these different tools that are really popular with data scientists and data engineers and analysts have been brought together into one platform. Databricks has put a lot of work into optimizing these tools to work together well, tried to optimize the UI to flow well, those kind of things. But fundamentally, from a data engineer perspective, I look at it as manage Spark, manage Apache Spark. There's a lot of other benefits to it, but that's kind of the core need I want Azure Databricks for. It saves me a lot of setup and hassle getting getting Apache Spark working, and just makes it easier for other people to jump in and use Apache Spark. It provides a lot of performance optimizations, especially as you integrate different tools that are all part of the Databricks stack. But as we look at Azure Databricks, we'll see that there's optimizations and libraries already ready to work with other Azure resources. So within Azure, you're going to get some more built-in capabilities for other Azure technology as well. And one of the really cool features, if you don't know about this, is Azure Databricks makes it really easy to auto-scale your clusters and auto-terminate if no one's using them. This idea is becoming more and more popular, but I've been waiting for this for basically my whole career. Azure Databricks does it very well. Interfaces for Databricks. So I won't go too deep into this, but we'll look at using notebooks, which are a lot like Jupyter notebooks, if you've worked with those. We will talk about, I want to mention to you that you can use the IDE. Often, day in and day out, I'm using PyCharm and writing Python code, and I can run that on Databricks with this thing called Databricks Connect. You have a REST API that's specific to Databricks, and so we kick off our jobs that way. You might create clusters through this API. Quite a few things you can do with the API, a lot of it on the management side of your Databricks resources. And then Azure Data Factory, I look at as a very useful orchestration tool in working with Databricks. So you might kick off a notebook or some kind of saved job from Azure Data Factory and have some steps downstream that read the output and do some other types of ETL or whatever it is you're after. With that, let me give you a quick demo of just how we query data in data lakes, what it looks like from Spark. It's not that different from using a SQL database, but I want everyone to see that. And then a quick overview of the Databricks workspace so that as I'm talking the rest of this session, you know what the heck I'm talking about. So here we are in a notebook inside Databricks, specifically Azure Databricks, of course. And so what I'll be doing is taking New York City trips data. The reason I'm using this data is because there's quite a bit of it and you can get access to it from any Databricks environment or really any environment you want. It's pretty open public data. What we will do with it is create a schema on top of the raw data. What's happening first is I've made a copy of some of the raw data into my own Azure Data Lake storage location. We'll talk more about what that means, but basically it's Azure's cloud storage system. And the reason I did that is to get it from something like 1.6 billion records down to something like 80 million records. So just to simplify this for us. And the first thing that needs to happen is a table needs to be created. So in this example, we create an external table. If you've used Hive, if you use some other tools, you may know the difference of external tables versus regular tables, but basically this is applying that schema on data that's sitting in the file system without moving the data, without changing the format. So we're saying, here is a schema that is correct for the data in this folder within Azure Storage, and when I run my query, it will find out if I'm right or not. So you don't really need to do this if you're a normal analyst and someone has built these foundational tables for you, but it's a very good example of how you would get started. If it's a new data set, you know it's in the data lake, but you don't have a table ready for you to query. Once we have done that, that was pretty quick. It only took 1.8 seconds. We can do a simple count one off the data and get a count. And what I want you to see here is if you've worked with relational databases a lot, the time it takes is more than 16.5, or the time of 16.5 seconds to get your count on this table is quite long. There's not the same level of query statistics and other capabilities that help you get really quick counts. Indexing is not really a thing. We do partitioning instead. So you're just going to have a different experience. But you can still issue SQL statements that look very much like the SQL statements you would do from really any database system you use. The next thing we're going to look at is slightly more complex queries, still not doing a whole lot here, but we can do a select from with the where clause. In this case, the where clause doesn't really save us too much time because it's applied after the fact. And then we can limit it to 10 or 100 records just to get a sample. So this is your first glimpse into what this data looks like. You might be able to notice that there's some weird things in here because we applied the schema at the end. The way we identified that there's headers in it didn't quite take effect the way I would want. Typically, we'll just filter those out. Often we're going to copy from external tables into final tables, or at least those enriched tables I talked about. Delta Lake is a certain type of file format. So instead of saving it as a delimited file, or say an Excel file or a JSON file, we're going to save it as a Delta file. There's a little bit more than just the format that comes with it, but the thing to know is if you're working with Apache Spark these days, especially if we're working with Databricks, it provides quite a bit of optimization for things like querying and how it handles partitioning. And so in this case, we can create a table from an existing table. So we create table using the Delta format, partition by a certain partition, and we've done this with a simple select statement. We're going to break out the year and month separately, and we're going to reference that same external table. So it's a really easy way to create a better performing table, in this case managed by Spark with some good partitions. Once we've done that, we can do a select from that, and we're doing just the top 10, and we should see much quicker results there. There we go, less than a second to get the top 10. That seems more reasonable. The schema was applied, and so it cleaned up some of this for us, it looks like. And then now we have an example of just a little bit more complex statement where we've got a group by, we have an order by, we have things that look like they would run in pretty much any database. I can run that pretty quickly, I get those results. With a larger data set, it starts to slow down. If you want to return a lot more detail, of course it's going to slow down, but half a second. I probably wouldn't want to put this behind a website that a lot of users are hitting, but if an analyst is exploring this data, that's really not bad performance for them. And then just a quick peek behind the curtain for you is that the Delta table was saved in this location, which is kind of a default location for storing managed tables in Azure Databricks. And main thing I just want you to see is that there is this log that's very important for Delta type tables, but then there's also these partitioned folders, which is what's going to allow us to filter on something like a certain month and year and get quicker results than if we leave that filter out. For those interested, the initial external table is built on this, and so we have CSV files that are gzipped, and that gzip compression does really speed things up. So with that, let's do a couple-minute overview of the Databricks workspace. So I'm in my Azure Databricks workspace. This is my home screen. I have recents. I have some clues as to all the things it adds. There's ML flow. I can add jobs, schedule jobs through it. I can create notebooks like what we were just using. I can create tables through a UI if I choose to. I can do quite a bit of management of my cluster and my data and my notebooks. And one of the important things, if you decide to go try this on your own, especially if you get Azure free trial and use the 14-day trial they give you, is you can come in and create your cluster. Quite a few settings here. They're really not that complicated. I should have a video on YouTube still that walks through some basics, but quite a few different versions of the runtime, and very exciting to see that it is 7.3, which is Spark 301, Scala 212, very modern version of Spark. The auto termination I talked about can all be configured right here, the auto scaling, so some really cool features. And then if you go to advanced options, you can set init scripts that kick off every time you run a cluster, set up logging, and all kinds of great Spark configurations can be added on this screen. For data that you have stored as tables, which I didn't really register too many tables yet, that shows up in this data tab. So someone could come and browse the schema and everything just by going to the data tab and looking around. And it even gives you some clues on the size of the data, number of files, since that starts to matter a lot in your data lake. So that's the super quick overview of the Databricks workspace and what you would need to know to just kind of get started. Let's continue on to learn a little bit more about the Azure ecosystem for data lakes. So now we're going to look at a reference architecture which shows sort of a very basic view of how I tend to build data lakes. The first thing we're going to start with is the simplest view I can give you, which is your data comes in from different sources such as databases or especially applications, your web application or mobile apps that your company has. It could flow into Azure Databricks. That gets a little trickier as to what happens in the middle, but that can flow into Azure Databricks, or Azure Databricks could go get that data directly from a database. And then we would use Azure Databricks to save that to Azure Data Lake storage. That process is probably iterative. You probably save that raw version like I talked about. You do some transformation. You maybe join in some additional data. You save it back to Azure Data Lake storage. So that's the simplest sort of architecture you can expect to use. And that doesn't quite support streaming use cases, which is how you normally get that application data in. So if you're starting to get just slightly more complex here, for the streaming data, you would follow the path on the bottom here where the applications would have, the services behind the applications would send their data to event hubs. Event hubs is similar to Apache Kafka. We'll cover that very briefly in a bit. Now, if it's batch data, you have some options. You could still use Azure Databricks to get that data from like a database table every 30 minutes or once a day. Or you could use Azure Data Factory, which is a low-code or no-code ETL tool built into Azure. And you could use that to do direct copies of database tables into Azure Data Lake storage. You can do quite a bit with it if you choose to. You can do mapping data flows, which actually run Spark under the covers. My typical recommendation for the types of teams I've engaged with is use Azure Data Factory for coordination and scheduling jobs that have a lot of dependencies, and maybe use it for some basic copies of data just to get it into your data lake. But for the more complex logic, I find that Azure Databricks gives us a lot more ability to customize and scale that over time. Basically, we just have more control over what we're doing in Azure Databricks. That doesn't mean that's right for everybody, but that's my quick glimpse and why I'm not going deep on Azure Data Factory as well. So I told you that Azure Databricks for a data engineer is basically Apache Spark. That's the core thing it offers along with all the fancy stuff it adds on the top. So why use Apache Spark? We talked about how important it is to have scalability and auto-scaling being a big factor, and Spark can do those types of things for us. It has a relatively easy to use API and it's very general purpose, so I can do a lot of data processing with it. The basics of horizontal scaling are pretty easy, but just to make sure we're all on the same page here, if I had one very strong, very specialized person doing a job that required, let's say, picking up sticks across a field, I'm probably better off getting a whole bunch of people that aren't really that experienced with picking up sticks, but are willing to do the job, give them each a section, let them do that work, and have them all come together and throw them in the final bucket at the end to take them out and get rid of them. So one person doing the job is not nearly as powerful as many people doing the job. That's the basic idea of distributed computing. It also gets way more complex which we won't go deep on today, but that is the warning that distributed computing gets more complex than running on a single server. So, talking about what Spark is, it is a general purpose data processing platform that can work really fast by utilizing memory well. It has pretty simple code and it lets you do parallel compute and distributed computing with pretty simple code. They have a few different ways of using that API via Scala, Python, Java. You could use it with R as well. C#'s making a rise, not so much in Azure Databricks, but in Azure Synapse, which is a newer, not quite generally available tool. And you can do batch processing, you can do stream processing, you can do machine learning. There's some other add-ins to Spark that allow a lot of different use cases to be fulfilled with it. And you can run Spark on a few different execution engines. So you have the API. When that code runs, it does need to run on a cluster of machines. You can either have like a Spark cluster, you could run it on top of Yarn, which is what your Hadoop clusters would be using. You can even run it local just on your laptop, and this isn't normally how you would schedule any jobs, but it's great for development or getting started. When we take our distributed computing concept, what you need to remember is that there's some type of controller node, controller server, and on there we run a driver application. And that application is going to send a bunch of tasks out to the different workers. They'll do a whole bunch of processing, and in the end, something's going to come back to that driver program that's running on our controller box. Typically, with the type of stuff we'll see, what comes back to the driver is really like a status message that we finished the writes, because we don't collect all that data back to the driver very often in the real production situations. Let's look at the API and let's talk about the difference between batch and streaming as well. So the way you would change your code from batch to streaming, it can be pretty simple. There certainly are some complexities to it. We'll look at some of those later, but you go from spark.read to spark.readstream and you're now in streaming mode. You are importing a different module, but that's a simple change, and now you're able to take your pretty similar configurations. For some formats it's identical, and run a read using streaming or batch. Let's talk about the storage we're going to use. We will use Data Lake Storage Gen 2. I will talk about it as Azure Data Lake Storage throughout, sometimes abbreviated ADLS. What you need to know is that Azure Storage is your distributed storage system within Azure. Within that, you have some different options of how you configure a storage account. We can do a hierarchical storage account, which is your Azure Data Lake Storage, and with that, we get all the same capabilities of Azure Blob Storage if you've been using that or still use that. We have Hadoop compatible access, so Hadoop libraries work really well with this Azure Data Lake Storage. We have similar permissions to what you would do in a Unix system. We have optimizations for cloud analytics workloads. The pricing's pretty similar. You're probably going to pay a little bit more for your Azure Data Lake Storage. It's always good to run some proof of concepts to make sure you know what that bill is going to turn out to be before you launch your full projects. But basically, it is focused on this exact use case: building data lakes, doing analytics, building it out with large files primarily, meaning more than 100 megs, and using tools like Spark or Hadoop with it. Now, Event Hubs for Kafka is how I'm going to access my Event Hubs platform. And the reason we're using Event Hubs, which is the same reason I would choose to use Kafka if I wasn't in Azure, is it's a reliable place to stream the events, and it decouples that data from the destination. So your web application just sends data to Event Hubs, same way it could send data to Apache Kafka if you're working with open source technologies instead. And it doesn't need to know that much about who's going to consume it. You could have multiple different analytics teams consuming it right off of Event Hubs. They don't really get in each other's way. They don't have to worry about what the other teams are doing. The only thing you need to know is what is the schema of that data being sent, and you need to organizationally figure out how do we tell people we're changing the schema. So it's a scalable message broker. That's the shortest, clearest definition of what it is. And it's really good at keeping up with both the producer and the consumers and allowing a bit of buffering there. If your consumers stop working for a bit, the producer doesn't care. So to picture the decoupling, this little diagram here is showing if you have just two simple data sources, our trip data and our vendor data from the top of the diagram, those go into Azure Event Hubs. And from there, we have the data flow to data lake. We could have it also flowing to some real-time report, and we can have it flowing to some kind of user dashboard. Say we have this D3 JavaScript dashboard that reads directly from Event Hubs to show the latest activities and events. So those different consumers are completely decoupled from each other and completely decoupled from the source data. It's just a matter of passing data along and keeping the schema consistent so that everyone can do their part in this distributed architecture. A few key concepts to cover real quickly. You would have an Event Hubs namespace, which is kind of your Event Hubs resource you deploy. Within that, you can create Event Hubs. Event Hubs translate to Kafka topics. It's similar to how you would name a table. You would have your trip event hub and your vendor event hub. Typically, I want data of the same schema in the same event hub, which is what we'll see in my example. We deal with partitions and consumer groups conceptually just like what Kafka does, but I'm able to define scalability differently. I'm defining it as throughput units, and so I just kind of change that dial on event hubs, and it's going to change how much throughput I have versus if you're managing Kafka yourself, you're installing new servers and adding them and shuffling everything around on your own. So let's take a look at loading the data lake. We'll look at a batch and streaming example that are all part of that same reference architecture use case I talked about. So here's our Azure Databricks notebook with all of the code that we're going to look at. We start by loading up some variables and setting a Spark schema. This is one of the many ways to set that schema. Then we load up a lookup table that we'll use to get the service zone and the zone. So we have a display of that data for you to check out. And then here's our big data set. We start with a Spark read where we apply a few options, and we're going to that same Databricks datasets folder. So this you will have access to if you spin up your own Azure Databricks cluster. Then we do our first batch of transformations. There's two different ways to do that. I've got an option A and an option B. One is the more, programmatic type API where we're adding with column, and there's some different things we can do with the data frame from that perspective. The other is more SQL expression syntax, and some people really prefer this because it looks like the type of SQL statements they're used to writing every day. It's really just a matter of preference, except when you're doing quite a few with columns, it starts to mess with the query plan and slow things down a bit, whereas one giant select statement, even though it looks ugly, it will run better on Spark usually. The query optimizer knows what to do with it a little better. Now, we want to join to that lookup table I talked about. We will do that by having a input data frame, a transform data frame, that zone data frame that we create, and we need to specify our on clause, and then of course, whether it's a left join or inner join. Inner join is your default, which you might assume, and then we need to rename a few columns just to make them more clear. Finally, we have one big write statement. It's really just a couple of options plus this really important partition by so that we can optimize querying data based on the year and month of the pickup. So that data has been written. It took about 5 minutes to process those 80 million records across 2019 directly from the shared dataset location. Now, the streaming job, we have a few settings at the top that you can dig into on your own. If you are going to use Event Hubs for Kafka the way I am doing, this example, lines 13 to 26, are good to reference on my GitHub repository because you may not find the right one if you do a search. So this should hopefully help you get that right the first time. Now, we have a read that looks very similar to what we did before. It's a read stream instead of a read, and our format is Kafka, and then we pass those configurations. Now we have a few extra steps. That data comes in as a Kafka record. It has a field called value, which is bytes. We convert that to a string, and then we use a special function that says, I have a string of JSON data, and I know the schema of that data. Can you please convert it to a record, to a struct within my Spark data frame that I can then reference each field on its own? So all this does is takes that JSON string, makes it into something where we can reference each item, and our very next important transformation is we unpack all of that into separate columns. So JSON.star will basically select each of those to the top level, and then we apply the exact same transformations that we did in our batch job. This code is identical to what we did before. And then at the very end, in this case, I am simply displaying so you can see what kind of data is being output. This is the command to write it to Delta to that same path that we used for the batch job. and you can run this and it'll start to write that data in a streaming fashion. It'll create a lot of small files, so there's some things like Delta Optimize that you'll want to use to compact those in a real world situation. And then we can also be reading the data that's being written there with this read stream command. So we're reading out of files. We're reading streaming data out of files. I don't believe I'm actually writing to there at the moment, so it's just kind of reading whatever is already there. But as I trigger this, then as new data comes in, it would keep pulling that into memory into this read stream data frame. Another thing to consider, which we won't go into right now, is you may need to send this data back to event hubs for multiple consumers to work with. If you're not just going to the data lake, you could publish the data to event hubs, and then you could always consume it downstream yourself, or let other analytics groups get that data that they need from event hubs directly. So to wrap things up, I want to come back to the idea of the file system practices we use. We talked about format as we went, but I didn't really get to just lay out some basics for you. So some storage best practices, super quick, are Azure Data Lake Storage Gen 2 is the way you would default to storage in Azure for a data lake. There are other options to consider, but this is kind of your default one to go with. Partitioning folders is very important. If you have data that's more than a gig, you probably want some type of partitioning on your folder structure. That's a deep topic, but please keep that in mind. That is your new way of indexing data since you don't have a relational database index or the types of indexes you'd see in a NoSQL database. For formats, Parquet format or the Delta format are the most common ones for storing data for analytics. There are others like ORC. Avro has quite a different set of properties. These are all like big data formats you can read a lot more about, but if you need to do this today, don't keep the data in CSVs. Try out Delta or Parquet depending on the environment you're in. And if you're going to compress the data, make sure it's splittable compression. You can find answers to that topic on your own very easily. Small files are a problem, so you want your files to be more than 128 megs. So let's call out a little bit of the negatives real quick. But I'm going to tell you how we solve that. Spark is very powerful. We've talked about that. It's very scalable. It's not ACID compliant. So you can get corrupted data saved to your folders. If you do, you then have a difficult time cleaning it up. The schema is not really enforced on writes typically, and so you may have situations where you want to enforce that schema on the write to the folder. When you have small files like we talked about, it's not efficient for reading. There's just too much file I/O happening. It's not built for lots of small files, and it can read too much data. It doesn't always take advantage of partitionings properly. It certainly doesn't take advantage of other indexing and other statistics that it could use very often. The way we're going to combat that in Azure Databricks is using Delta Lake. So Delta Lake is relatively new. It is open source, but the Databricks Delta format is a bit different than the open source Delta format. So I'm going to focus on the Databricks Delta and keep it straightforward here. So it's going to give us ACID compliance. It's going to give us schema enforcement, and we can turn that off or on. It's going to give us some tools to compact files, to collapse our small files into larger files on a regular basis if we choose to. It's going to give us quite a few performance optimizations. And missing from the list is it gives us time travel, which is my favorite feature ever. Basically, it lets us go look at what the data looked like, a day ago or a week ago. You probably don't save it for too long, but you might save 7 days of history there and be able to kind of see what your data look like then compared to now. The core of this all is the Delta log. The simplest, quickest explanation of the Delta log is that it is tracking via JSON files the different commits that have happened. So each time I do a batch load, I'm going to see some changes to my Delta log files. I don't need to worry about it. I don't need to think about it, but I can go try and poke around if I want to. The actual data is going to be stored in partitions if that's how you set it up, and then in Parquet files. So I talked about Parquet versus Delta. We're still using Parquet, but this Delta log gives us all these capabilities that I just said were kind of a bummer that Spark doesn't do them that easily out of the box. So my final thoughts for you are that regardless of your experience, you can go and use a data lake and query that data lake with Spark, especially if you're using Databricks. I also want to encourage you to Explore Spark a bit more, even if you just run it locally on your machine, to make sure you aren't paying any cloud costs, to get a feel for what it can do, because it may come in handy in your career if you're not already using it. And I also wanted to share that there's a lot to the best practices for file storage. So don't do it alone. Do a lot of research, listen to a lot of discussions at conferences like this, ask others for help, come to my meetup, we can talk about it there, those kind of things. So I've got a list of references that'll be in the slides I shared. I have more material on dustinvannoy.com. I'm hoping to add more and more in the future, but 2020 has been quite the year, so we'll see what happens. And I will continue to update about user group meetings and other things I publish if you want to follow me on LinkedIn or Twitter. So here's my contact info. Thank you so much for your time. I hope this was meaningful to you.